Now we're going to introduce a new concept, a really powerful concept called multi-stage builds. If you see the Docker file that we have right now, we're using the from Golang 124 base image, and we're building our entire Docker image based on this image right here. If we see the output of Docker images, you can see that our Docker basics image weighs 1.26 gigabytes. And this is because this image we have right here has a whole Debian operating system and also installs Go on top of this Debian. And this is impacting the final weight of the image that we are going to generate. Multi-stage build is a technique that allows you to use multiple from keywords in the same Docker file. So you can have one stage for building your application, and you can have a whole different stage for serving the application that you just created. Every time you use a from keyword, you can also use the as keyword in here to define a name for this stage. In this case, we are going to call this builder. In this case, all this stage will be called builder. We want to have our Golang base image in here. We want to define our work there, want to copy everything from the build context into our /application. We want to run Go mod download so we can download all the dependencies for our Go application. And finally, we can build our application and create this binary that is the one that we are going to execute. For all of this, we can see that we required Go to be installed because we are using the Go command in this stage. Now, after we finish building our image and we already have a binary that is ready for us to be executed, one thing that we can do is define a complete different stage in the same Docker file, but now we want to have this stage as the final stage in our image. For doing that, remember, multi-stage builds allows us to use multiple from keywords in the same Docker file. So now we can execute from, and here we can use a much smaller image for deploying our application, for shipping our application. In this case, we will use Alpine. Now this Alpine image is a minimalistic based image based on the Alpine Linux distribution. It is designed to be lightweight, secure and efficient, which makes it ideal to build small and fast containers. It comes with only the bare essentials, so there's no extra bloat in there. And because of that minimal footprint, it also has a much smaller attack surface, which means better security for the applications that you are delivering. One thing for you to know is that Alpine uses Muscle instead of the glibc, and it comes with an ash instead of a bash. That means that in here we don't have some C libraries that we do have available on standard Linux distributions. In this case, we are going to base our serving stage on the Alpine image. And same as before, we are going to use an alias for this, and we are going to call this serve. So we have one stage for building our application and a complete different stage for serving our application. And you can see the moment we put another from keyword here, you can see a line right here showing us that this is one stage and this is a complete different stage. Since we are working on a brand new stage here, and as you can see, this is a brand new image based on a brand new operating system, whatever we did from this stage is not available in this stage that we have now. After defining the from keyword and installing our operating system, one thing that we want to do is copy. And we want to copy from, and here we can pass from which stage we want to copy content. In this case, we want to copy content from the builder stage. And what do we want to copy from the builder? We want to copy this /application, and from this folder, we want to copy this binary that is the one that we created when we use Go. So in this case, we want to copy /app/application, that is this binary, and we want to copy that into the current folder. So you can see that we are copying from a different stage, and we are copying just a part of everything that is inside this folder. We are only copying this binary. If you remember, in our /app folder, we have the entire build context that we pass when we build our image. But in this stage, we only want to get the application binary, that is our application ready to be executed. Since we already have our application binary right here, we want to have our environment variable in this stage because these environment variables are used when the application is executed, not when the application is being built. And since we have this binary, we can execute it in the exact same way we were executing before. But remember that we build our application based on this Debian operating system, and we are running our application based on this Alpine distribution. Now, whenever you build Go programs, you need to build them for the exact platform that you are going to run them on. So we need to add a few more flags to the Go build here in order to ensure that this application binary can be executed in the operating system that we are going to use later for executing our binary. So here we are going to pass a few arguments to the Go build. The first one will be Go OS, and we are going to use Linux in here because this Alpine is based on a Linux. We are also going to pass Go Arc, and here we are going to use AMD 64 because that's the architecture for this Alpine image. And finally, we are going to pass a different flag called cgo_enable, and we are going to pass this in 0. The reason we are passing this flag to the Go build is because we are building our application using the Debian operating system, but in Debian you do have C libraries that you can use that are not available in the Alpine version. So we need to ensure that the output of this Go build is built for the exact operating system where we are going to execute this binary. In this case, Debian has some C dependencies that we can use, which we don't have in the Alpine distribution. So in Alpine, you don't have C libraries. That's why you need to build applications to disable C integration or the use of C libraries in the binary that you are going to execute. As you can see from here, this is our multi-stage build. So we are building for the right operating system, architecture, and configuration where we are going to execute our binary. Since we are generating this binary in this stage, we need to ensure that we are building exactly for the platform where we are going to run. Now with this Dockerfile, we can go back to our terminal and execute docker build, pass the name for our image, and pass the building context. And you can see that now we are going to use two different metadata from two different images, one for the Alpine latest and one for Golang 124. Up until to this point, it is using the first stage of the building process. And here you can see that we are building the application for this operating system, for this architecture, and with this configuration. Once we have finished, you can execute Docker images. And now take a look at our Docker basics, weighs 19.8 megabytes, compared with the 1.26 gigabytes that we had before. So we can use 19 megabytes to deliver our application instead of using 1.26 gigabytes, using a lot less space, being much more efficient, and taking less time to install our application and to run the application. And now we can just run our Docker basics image like this, and you can see that we can curl from localhost 8080/ping, we get the pong here, and if we execute docker ps, we are based on Docker basics. This is the image that we are using, and if we use Docker images, you can see that our Docker basics is weighing 19.8 megabytes. So we're getting the exact same response, but using megabytes instead of gigabytes. That's a massive improvement just by switching to multi-stage builds.